Welcome to Section 2, Lesson 8. Across the previous 7 lessons, we built every algebraic expression skill. The rest of the course depends on identifying terms and coefficients, combining like terms, distributing across single and nested parentheses, evaluating at numerical inputs, translating English to algebra, dodging the translation traps, and recognizing the 6 standard expression templates. Today is the marathon lesson where we apply all of those skills back to back on a mixed sequence of problems. Mixed practice is the most efficient learning move in all of mathematics because it forces you to first identify the type of problem and only then apply the relevant rules, which is exactly what tests and real-world applications demand. Single skill drills leave you fast at one task, mixed marathons leave you fluent at the whole toolkit. First idea on the board: mixed practice exposes the soft spots in your skill set in a way that single topic drills never can. When every problem in a homework set is a like terms problem, you settle into a rhythm and your reflexes carry you through even when you do not really understand the rules deeply. When the next problem might be a nested parenthesis simplification or a word to algebra translation or a percent template equation, you have to first decide which toolkit applies and only then start working. The decision step is exactly where weak students stumble and strong students breeze through. Today we exercise that decision step deliberately by mixing problem types in a deliberate sequence. The full Section 2 toolkit has 7 skills, and you should be able to name them all from memory before starting the marathon. The skills are identifying terms and coefficients, combining like terms, distributing factors across single parentheses, simplifying nested parentheses with the innermost out rule, evaluating an expression at numerical inputs, translating English sentences into algebraic expressions using the keyword dictionary and trap library, and recognizing the 6 standard expression templates. Every problem in the marathon today exercises some subset of these 7 skills, and the first move on every problem is identifying which subset is in play. Third idea: speed and accuracy on mixed problems come only from reps, never from rereading the rules. The rules are short enough that an hour of careful reading covers all 7 skills. The fluency that lets you solve a mixed problem in 30 seconds rather than 3 minutes comes from 40 or 50 practice problems spread across the next week of homework. The marathon today is a starter set. Commit to working a similar mixed set on your own time over the rest of the week, and the Section 2 material will lock in as automatic background knowledge that the rest of the algebra course can build on without conscious effort. The full Section 2 toolkit has 7 skills, and a marathon-style mixed practice session is the most efficient way to lock them in as fluent reflexes. The first move on every mixed problem is to identify which skills the problem requires. Only after that identification do you apply the relevant rules. Today we make the identification step explicit so you can train it deliberately rather than absorb it by accident. Skill 1 is identifying terms, coefficients, and constants in any expression. Skill 2 is combining like terms to reduce an expression to its simplest form. Skill 3 is distributing a single factor across a parenthesized sum. Skills 1 through 3 together cover most pure symbol simplification problems and form the algebra mechanics layer of Section 2. Skill 4 is simplifying nested parentheses using the strict innermost out workflow with a careful sign check at every layer. Skill 5 is evaluating an algebraic expression at numerical inputs by substituting in parentheses and applying PEMDAS. Skills 4 and 5 cover the harder symbol problems and the bridge to numerical computation. Skill 6 is translating English sentences into algebraic expressions using the keyword dictionary and the trap library. Skill 7 is recognizing one of the 6 expression templates and substituting the specific numbers into the canonical form. Skills 6 and 7 are the word problem layer and represent the highest leverage application of all the earlier skills. When you face a mixed problem, the workflow is first read the problem and identify which skills apply, second order the skills if multiple apply, third apply each skill in turn, fourth verify the final answer by reading the result back into English or substituting into the original expression. Today's two worked examples each combine 3 or 4 skills. We walk through both with the identification step made explicit so you can practice the decision-making layer rather than just the mechanics. Here is the first marathon problem. Simplify the expression 3 times the quantity 2x minus 1 minus 2 times the bracket containing x minus the quantity 4 minus x. The problem is a pure symbol simplification that combines the distribute skill, the nested parentheses skill, and the combine like term skill. 3 skills layered into one expression, exactly the kind of mixed challenge the marathon is designed to train. Step 1. Identify the skills required. The expression has parentheses inside brackets, which means nested simplification with the innermost out workflow. It has multiple distribution opportunities. It will require combining like terms at the end. 3 section, 2 skills in play, and the order is innermost out from lesson 3 followed by combine from lesson 2. Step 2. Distribute the innermost negative across the inner parentheses. The phrase minus the quantity 4 minus x becomes minus 4 plus x because the negative flips the sign of every term inside. Substituting back, the bracket now reads x minus 4 plus x. Step 3. Combine the like terms inside the bracket. The 2x terms combine to 2x, and the constant negative 4 stays. The bracket simplifies to 2x minus 4. The expression now reads 3 times the quantity 2x minus 1 minus 2 times the bracket containing 2x minus 4. Step 4. Distribute both outer factors. 3 times the quantity 2x minus 1 becomes 6x minus 3. Negative 2 times the bracket containing 2x minus 4 becomes negative 4x plus 8. The expression now reads 6x minus 3 minus 4x plus 8 with all parentheses and brackets gone. Step 5. Combine the like terms in the final flat expression. The x terms 6x and negative 4x combine to 2x. The constants negative 3 and positive 8 combine to positive 5. The fully simplified expression is 2x plus 5. So the final answer is 2x plus 5, achieved by layering the innermost out distribution from lesson 3, the like terms combined from lesson 2, and the careful sign tracking from the trap library. Mixed problems like this one are the natural unit of work in the rest of the algebra course, and fluency comes from reps. Here is the second marathon problem. The sentence in 12 years, Alice will be twice as old as she is now. Translate this sentence into an algebraic equation that lets you solve for Alice's current age. The problem combines the words to algebra translation skill, the trap library twice as many trap, and an age template pattern that pulls together everything from lessons 5 through 7. Step 1. Identify the unknowns and assign a variable. Alice's current age is the simpler quantity and her future age is described in terms of it. Let A equal Alice's current age in years. Then Alice's age in 12 years is the algebraic expression A plus 12, since 12 years from now means add 12. Step 2. Translate the will be phrase. The phrase will be is a future tense form of is, which from the keyword dictionary maps to the equal sign. So the sentence in 12 years Alice will be twice as old as she is now becomes the equation A plus 12 equals twice her current age. Step 3. Apply the twice as many template carefully. From the trap library lesson, twice as many means the multiplier attaches to the smaller quantity, which here is her current age A. Twice her current age is 2A. So the right side of the equation is 2A, and the full equation reads A plus 12 equals 2A. Step 4. The equation A plus 12 equals 2A is the clean translated form ready to solve. Recognizing that this is a one-variable linear equation finishes the translation phase of the problem, and the rest is straightforward algebra in section 3. We can preview the solving briefly. Subtract a from both sides to get 12 equals a, so Alice is 12 years old now. Sanity check, in 12 years she will be 24, which is twice her current age of 12. Translation confirmed. So the translated equation is a plus 12 equals 2a, and the solution is a equals 12. The big lesson from this marathon problem is the layering of skills: keyword dictionary for the words to algebra, trap library for the multiplier direction, and template recognition for the one variable linear form. Each skill from the section contributes a clean piece, and together they produce a solvable equation in under a minute. Aiming for that under a minute pace on every word problem is a realistic goal once you have done 40 or 50 mixed practice problems on your own time. 3 patterns that catch every algebra student during their first weeks of marathon-style mixed practice. Each one is fixable by a small explicit habit applied between problems and at the end of every problem. First pattern: applying the wrong skill first because you misread the problem type. A student sees a word problem and starts distributing parentheses inside the original sentence rather than translating to algebra first, or the reverse, sees a symbolic expression and tries to translate it back to English rather than simplify it directly. The cure is the explicit identification step at the top of the workflow. Read the problem, name the skills required, then apply them. The identification step costs 10 seconds and prevents an entire wasted attempt at the wrong skill set. Second pattern: carrying the previous problem's mental model over to the next problem. The previous problem used the percent change template, so on the next problem you reach for a percent template, even though the new problem is a perimeter problem. This carry-over error is unique to mixed practice and is exactly why mixed practice is so valuable for diagnosing weak spots. The cure is to consciously reset your mental model between problems, take a 1-second pause, reread the new problem from scratch, name its skills before starting work. Third pattern: skipping the verification step because you are in marathon mode and trying to move fast. Mixed problems hide errors more effectively than single topic problems because there is no rhythm to fall back on, so the read aloud verification step is even more valuable in mixed practice than in regular homework. Always read your final answer back into the original problem, in English for word problems and in numerical substitution for symbolic problems. The verification step takes 5 to 10 seconds and catches the vast majority of mixed practice errors before they become wrong final answers. Mixed skill marathon practice is the dominant style of math evaluation across nearly every standardized test, contest, and applied setting. Specialized single skill practice is useful for building each individual skill, but mixed practice is what builds the fluent decision making that real-world math problems demand. 4 broad domains below. On the S8 ACT, GRE, GMAT, and most state algebra and SAT subject tests, the math sections deliberately mix problem types within each section so that students must first identify the type of problem and then apply the relevant skill. Test writers know that mixed practice is the gold standard of fluency assessment, so they test in exactly that style. Students who have done 40 or 50 mixed practice problems before the test consistently outscore students who only did single topic drills, even when both groups have studied the same total number of hours. On the AMC/AIM math counts and other contest math problems, every problem combines 3 to 5 skills in a single expression, and the contestant has roughly 2 to 4 minutes per problem. Recognizing the skill set required and applying them efficiently is the entire game in contest math, and contest students train mixed practice intensively for exactly this reason. The skills you are building this week in Section 2 extend directly into contest math fluency for students who choose to pursue it. In oral math exams, whiteboard interviews for tech jobs, and oral defense exams in graduate school, the examiner jumps between topics rapidly to test whether the candidate has fluent recall and decision, making rather than just textbook knowledge. The candidate has to identify the right skill from a quick spoken description and apply it cleanly on a whiteboard with no time to think. Mixed skill marathon practice is the only training mode that builds this kind of on-demand fluency. If you ever teach or tutor algebra yourself, every minute of every session is a mixed skill marathon because students bring questions across the whole curriculum and you have to switch toolkits constantly. The skills you build in marathon practice this week will serve you for the rest of your math life, regardless of whether you go into pure mathematics, applied science, finance, engineering, or teaching. 3 things to take with you from this marathon lesson today. Mixed practice is the most efficient learning move in all of mathematics, and the Section 2 toolkit is now complete enough that you can practice every skill in mixed combinations from this lesson forward across all the rest of the course. First, mixed practice is the gold standard of fluency training. Single skill drills are necessary for building each individual skill, but they cannot substitute for mixed practice when you need to recognize problem types and switch toolkits on the fly. Every standardized test, every applied math problem in science and engineering, and every real-world calculation in finance or contracts is a mixed problem. Train for the mixed condition by doing mixed practice as soon as the individual skills are at least passable. Second, the first step on every mixed problem is to identify which of the 7 Section 2 skills apply in what order. Identify terms, combine like terms, distribute, nested parentheses, evaluate, translate, and template. Read the problem, name the skills, then apply them. The identification step takes 10 seconds and prevents the wrong skill first error that wastes minutes of misdirected work on every problem it occurs in. Third, always verify your final answer by reading it back into the original problem context. For word problems, read the answer back into English and confirm it makes sense given the original sentence. For symbolic simplifications, substitute a specific numerical input into the original expression and the simplified expression and confirm they produce the same number. For percent and template problems, plug the answer back into the canonical form and check the equation balances. The verification step costs 5 to 10 seconds and catches the vast majority of marathon errors before they become wrong submitted answers. Coming up next, the lesson called Roleplay Contractor, where we follow a small business owner through a real-world series of algebra, heavy estimating tasks and watch every Section 2 skill come into play in the natural rhythm of professional work. The roleplay format also previews the kind of contextual problems that fill the rest of the algebra course.